All right, so here is a real-world example of running out of RAM. I got to experience this for the first time. So what I was doing was working on my software here, and I was working on making it so I could um, edit the endpoint name. And everything was going well, and everything was working, seemed to be working just fine. I can edit things like I was hoping to, and I've got it hooked up to the computer, showing all this debugging information, and everything was working just great. And I go and I come to try and turn the water pump on. I click it, and it didn't turn on like it's supposed to. It should say on and then start counting down from 15 minutes. And all my debugging information has stopped scrolling by. And if I start rotating the knob left and right, it doesn't show anything on this display anymore, but it is showing the serial output of when I actually write out when I turn the knob. These are actually run in the interrupt service routine for the rotary encoder. But all this stuff up here that was scrolling by constantly is running in the main loop, and that's totally stopped, and the device is totally frozen. It's not working anymore. So I go and I upload my program to it again, and I'm thinking, what on earth is going on? Is this just a fluke? What this was working just fine not too long ago, and the first thing the device should do when it finishes uploading here is it loads the EEPROM and then it goes to sleep. And so I will go here and try to wake it up, and nothing happened here, but I got to see in a serial monitor that it did run the awake, got that out, and then it read the battery voltage because I checked to see if I need to display a low battery warning or not. I was able to actually communicate with the endpoint. I was able to get the number of seconds that are remaining, and it did that fine. And I read the ambient light. I adjusted the RGB LED brightness, and I even adjusted the contrast of the display. But then it totally quit, and it's not working anymore. It's totally locked up here. And so I just went through and I was looking through my code, looking in my go to sleep function, and I was seeing, all of these messages that were showing here. How far did it get? Where did it stop at? And it got all the way through the go to sleep, and then I came up to my main loop, because after it finishes after it gets woken up, it does all this stuff, and it was able to get the battery, it set the battery light, set the display contrast, and it was in update display text where it had bombed out somewhere. And so when I further dug into it, I found the exact line that was causing the problem. It was this line right here. This is a line that I've had before. I didn't modify it or anything. And basically what it does is it just sets this text variable to have the number of minutes and the number of seconds that the endpoint is going to be remaining on, and whatever is set to this text variable will be shown on the display. What I did here was I commented it out and uploaded it, and you can see that now the program is working just fine. It woke up. I can interact with the device. I'm not showing the minutes and seconds anymore because I commented that line out, but this was the line that it hung up on. So I still had no idea that I had run out of RAM at this point. I was just so confused it didn't make any sense because this was working just fine. I haven't touched that. So I tried to just do some debugging. I put a debug statement in to just see if I could show the remaining seconds. Like maybe I had gone through and I changed the types of variables I was using, the data types. I changed these from integers down to bytes to make them smaller. They didn't need to be an integer. So I thought, oh, maybe remaining seconds is being miscalculated or something weird's going on. And so I can now see that the remaining seconds is calculating okay. I could see 52, 51, 50. So it's doing that all right. And then I tried to put the remaining seconds onto the text that's shown here, but it's not. So this was an even weirder situation. So I was telling it, put the remaining seconds onto this text variable, and it's this text variable that is shown here. The device is not locked up. It's just not doing something I told it to do now. So this was another level of weirdness. And I think at this point, it finally dawned on me that I did read at some point that there's this stuff called SRAM that's in the microcontroller, and Adafruit has a really good article about the memories that are inside the microcontroller, and has this picture of how the microcontroller allocates the memory. You've got 2 kilobytes of this SRAM on the ATmega 328 chip, and it allocates static data in a certain area. Then there's this area called the heap, and as it grows it goes up this way, and there's this area called the stack, and as it grows it comes down this way, and you can actually run out of this memory. There's only a finite amount about it, and I guess it's not very large, and it is possible to run out of this if you write a bigger program. They even give you this little function here called free RAM, which is supposed to measure the distance between the bottom of the stack and the top of the heap, and gives you the number of bytes that are available here. And you've got 2 kilobytes of this total. And they talked about how in the static data area, things like strings, like when I say over here display contrast, this is just a string. It's not changing at all, and then I'm putting on the display contrast that I calculate onto the side. But this string here, this is actually stored not only in the flash memory, but when the program starts running, it puts that string into the static data area. And so strings are kind of notorious for taking up a lot of wasting a lot of room in your SRAM, and it just reduces the amount of RAM that's available because it fills the static data area. And even though it doesn't change ever, it's still tying up some space. So so what I did was I put the free RAM command in, or function in here, and then I started outputting that just to see, maybe it says I have 0, or some very low number. And so when this thing finishes, sorry, there's going to be pauses while it's uploading here. Alright, so here we go, and so it's saying the free RAM is 167. So of the 2048 bytes, there's 167 bytes left. But even though it says there's 167 that are available, it is not doing something I told it to do. I told it to put the remaining seconds onto the text that's displayed here, and it's just not doing it. But it's not locked up. It's just not working all the way. So so when I read about how strings take up a lot of room, I went and I found some strings that I could make smaller. That I don't really use these strings at all. These are just IDs that are used in this library I use for doing menus. And so I just made the strings shorter, some of them. Even though it says I've got free RAM, I just decided, okay, I'll free up some of this RAM, and we'll see what happens. And when I made these strings smaller, and again I'm trying to display the remaining seconds, and it wasn't doing it before. Watch what happens now. Now it shows the remaining seconds. I mean, this is crazy. So and my free RAM, it says, is 189. So my free RAM went up a little bit when I got rid of some of these strings that were longer. I mean, I only got rid of maybe 30 or 40 characters here. But each one of those is a byte, and it freed it up, and not 30 or 40, but like 10 or 20. But that was enough to make it so that now it's doing what I told it to do. I told it to show this text. So kind of interesting. This is what happens when you run out of RAM. It can act really, really weird. And so in this article, they talked about how you can optimize your SRAM, and how, they talked about how the strings are notorious for using a lot of the SRAM. And there's this, what is it? It's a macro. It's called a macro called F. And what this macro will do is you can wrap your strings in it and make it so that your strings are not stored in that static data area of the SRAM. So I've got this really long string here that I'll show you. So it says I got 189 free RAM. If I go and I change this really long string to have the F macro wrapping it, it will prevent this string from being stored in the static RAM. It'll only be written to the flash memory, and then this F is actually replaced when it's compiled by some routine that actually just says go read whatever string is in the flash memory at this address. And so now when I go and wake it up, the free RAM is 269. So by using that F, that really made a big improvement on the free RAM. It had a pretty big effect. So what I'm going to do is go through and find strings like this, like this guy here, this debug one, and I'm just going to use this F macro to make them not be stored in this limited RAM area. They won't go into the static data area anymore, and that will solve the problem of running out of the memory. So yeah, that was my experience.